Hi, this is Dr. Prakash, Assistant Professor, Associate Dean, Srinivasan, Department of Civil Engineering, SR University, Bangalore. So today we are going to see surveying and geomatics. So why to study surveying? So as you all know, being a civil engineer, surveying is a basic of everything. So no structure can stand without knowing where to build. Before constructing a structure, the basic thing should be done, right? So first important thing you have to know is where you are going to build your structure. What is the topography of your structure? Whether your area is suitable for your particular construction. So everything should be verified. So that part is called as survey. Okay. It is the first step in every civil engineering project. It teaches you how to measure what is land, how to map it accurately with your project, understanding the features such as what is the where is the road, how long the accessibility for your particular land area, right? So road, buildings and bridges, which is built right on a right place. Okay. So another thing, it should be at the right level. Okay. So the level also should be maintained because due to your rainwater runoff, it didn't enter your building. So your required level and in the right way, the structure should be constructed. Because lot of things are there. So you should consider those everything. Okay. So what is the employability benefit of studying your surveying? Right. So there's a high demand in the construction, infrastructure, real estate, and government projects because everything you need a surveyor to initiate or start your construction. It open up a surveying firm, like a municipal corporation, public work and defense service. They are completely depending on the survey engineer to initiate or start any work of construction in their homes. So now we're going to see definition of survey. As I said, surveying it is a science and art to determine a relative position of a point above the or beneath the surface. So uh, you have to find the point. For example, if you are constructing a house, first you should regulate your boundaries. So your boundary should be identified. Okay. So that boundary has some endpoints where you are marking or starting, which include your boundaries. Okay. So within that boundary is your land, you can do whatever you want, but it didn't go to the other boundaries because it will always some other one. So to regulate that point on the ground, either on top or below, or it can be done in a direct or indirect measurements, like you need distance, you need direction, you need elevation. So collecting these necessary data, which is required for mapping, construction, and land development. So that is called as survey, right? So next is purpose of survey. So why we are doing survey? You can see here uh, in the map, it is clearly shown that the figure. So here you can see. So this is your point where you are starting. This is the boundary points where your land is located. So to mark this land, right? So you need to first fix the points which is required for marking your boundaries. Then you have to measure the distance. So this is your distance which you are going to measure. So those things will be done by a survey. So first one, you have to prepare a map and plan, right? So this is your map. So you can see there is a latitude and longitude located. So this line is located at north 27 degree, 54 minutes, 40-degree west at 140.3, right? So it is 30 degree. So this line is north 27 degree, 54 minutes, 40 seconds west. So every line has its own positioning, which is required to identify on the surface of the earth. Okay. Then to set out a construction work. Okay. So you can see in this picture, there is a construction work it is going on. So you are going to set out the boundaries. Okay, first you are setting out the boundaries on these lines. Then you are marking your link beam, so which is required. So everything can be done with the instrument which is theodolite. So this can be done. So that is your setting out of your construction work. Then determining the land boundaries. As I said, so you can determine the land boundaries. You can measure what is the length of your boundary from your measurement book, you can transfer that towards your ground area, so which is mandatory for your survey. So that is these are the purpose of your survey. Then divisions of surveying. There are two divisions. One is your line surveying. Next one is geodetic surveying. So what is line surveying? So in line surveying, you are assuming your earth is a flat and used for small areas. So you are assuming your earth is a flattened line survey, but actually your earth is not flat. Okay, so it is spheroidal. But in client serving, you're assuming your earth as a flat to make your measurement very easy. Because if you're considering the curvature of there, it is complicated. So for small area of land, it is suitable. So you can see here. So this is your geodetic, I mean, applying surveying. So next, going to geodetic surveying. So in this, you are considering your earth curvature used for large scale and precise survey. Okay. So if you are doing your surveying for a very huge area, so then you have to consider your earth as the curve. So you can measure your measurement very precisely on this particular. So here you can see, so this is your curvature. You are measuring, you are indicating your curvature with respect towards your curvature of that. So your measurement will be very precise on these measurements, right? So this type of survey, this division is called as geodetic survey. So based on purpose. Okay. First, how you are classifying your surveying based on purpose. First one is topographical survey. Next one is cadastral. Next, engineering, hydrographic, and next one is astronomical survey. So what is topographical? So it records natural man-made features. You can see here, so this figure clearly shows that this is a contour surveying. It records what is the level of the contour. So what are the locations? You can see there's a crack and there's a pinch. So everything is located here. So that is called as topographical surveying, which records natural man-made features on surface of the. Next one, cadastral surveying, which is land surveying. So it determines the document land and boundary. So you can see this is your plot area. So your plot area is this one. What is the area where it is located? What is the dimension of your plot? Everything can be observed from this cadastral survey. Next one is engineering survey. So it supports planning, design, and execution. So you can see this is the example how you are going to plan your road. So how you are going to execute, what are the area your entire roadway or railway is running. So how much is on government land and how much is on private land. Everything you can identify on engineering survey. When you're doing your surveying in a huge area, especially for your road construction, railway construction, or any other thing which is done by a government, then this engineering survey is supported. Then hydrographic surveying, it measures and map bodies of water. So in this you can see what this is hydrographic surveying. So here you can see how your river is flowing, what is the path of your river. So everything can be clearly notified or understand from this hydrographic survey. So this is very much important to map your ways of your rivers which is flowing on your land. So how much quantity of water and which direction it is flowing during your rainy season, how it will flow, what is the maximum water level, what is the minimum water level, how much quantum of water is flowing on this particular river, everything can be identified during using a hydrographic survey. Next one is astronomical. So it gives the position and point by observing celestial bodies. Okay, it gives which position in your Earth is located in your solar system. So with respect to your celestial body is nothing but a bodies which is outside on the space is called as celestial bodies. So you are identifying your position of Earth with respect towards your celestial reference from your celestial bodies. Okay. So this type of surveying is called as astronomical surveying. So next, fundamental and principles of surveying, right? So there are two fundamentals. One is working from whole to part. Next one is the location of point by measurement from 2 points. Okay. So this is your the traditional way of measurement. So establishing a border control framework first and ensure accuracy before detailing a small area. So what they'll do first, they will fix the boundaries. I mean, first they'll fix their boundaries, outer boundaries. From the outer boundaries, they'll be start measuring your inner area. So which will give your accurate, precise value of your entire area. So this is suitable for a smaller area because you are fixing your boundary. When your boundary is very less, you can directly measure it from your outer area. From the outer area, you are just quantifying your uh, area inside your larger area. So which gives your accurate uh, measurement of your particular plot. Then large framework first. So first you are framing your large framework first, then you are detailing a smaller one. So which can be easily identified and require you to measure your area very precisely. So this is suitable. Why they are following this? So minimize error propagation. So your error propagation will be very minimal when you are dealing with a large area to smaller area. Then location of point by measurement from 2 points. So this is nothing but you are using a technique from which you are locating your third point. If this is your point, you are locating this point with reference to this point and this point. By measuring a distance from A, make this as A and this as B and this is C. So the reference point of B from this maybe some measurement will be there. then from this point to this point, some measurement will be there. So this kind of marking is called as your marking determining a third point with reference of 2 points. Okay, we'll see this in detail. So now we are going to see that in detail in working from whole to part. So that in this you are going to fix your main survey line. You can see here. So these are boundary points A, B, C, D, and E. So what you are going to do is you are going to fix your boundary line. So this is your first point. From this you are going to measure your B, right? So this is your first measurement you are going to take. So these are control points of station point. You are measuring your outer area to fix your boundaries. So like that you are measuring all the distance. Then you are segregating your area into smaller triangles. Okay. So you may have a question why we should you divide your area into a smaller triangle. You can use a rectangle, you can use a circle, you can use a triangle. Sorry, you can use a square. But the thing is, only triangle is a shape which can easily accommodate in any irregular shapes. Okay. Even though your shape is like this, like your irregular shapes, you can divide your entire area into small triangle. Okay. So if you are dividing your area into small triangle, you will not leave any vacant space which is not measurable. So that is the reason why we are going with the triangle shapes to fit into your irregular shapes of your plot. Okay. Right. So we are here. This is a first triangle. You know the area of triangle is half into B into H. So then this is second triangle, third triangle, fifth, fourth is down, and fifth is here. So when you are adding all the triangles of area of all the triangle, you'll get your total area of your irregular plot. So you can cross verify it with your book because you are paying each and every square feet of area. Okay. So the thing is you shouldn't encroach other area, but you shouldn't lose your area which is belongs to you. So everything is paid, everything is accountable, right? So the thing is, you shouldn't encroach other area, but you shouldn't lose these things. So if you are dealing with these kinds of plots, you can use this working from whole to part. Okay. So next one is location of point by measuring 2 points, right? So you are going to locate point C, right? So there are techniques out there. We'll go through that in now, right? So yeah, what other thing you are going to do is there are 2 points A and B, right? With that point, you are going to measure your point C. So first measurement is you know the distance between B to D, that is D1, right? And you know the distance between uh, A to C, that is D2. So when you are connecting your D1 and D2, so you can draw an arc with a distance of D2 like this, and next draw an arc with the distance of D1 with this. So the arc which is intersecting, that point is called as point C, right? So that is a way of fixing your third point with respect towards your reference of 2 points. There are another one method that is with your right angle triangle, which is called as offset. So you should know the distance of your point which is located from B to C. From that, taking your right angle, you should know the distance D2, right? From that, you can easily fix your uh, point C. So this is second method. Third one, by reference of your angles. Okay, right? You should know the inclined angle between your B to C and the distance between your B to C. So with this point, you can easily measure, right? So next one is with reference of two angle, right? So you should have two angles with that reference. You can measure the point which is intersecting. You can easily identify, right? In a similar way, the distance from A to C, which is called as a D2, and the angle from B to C with that measurement also, you can mark your point C. So these are various techniques which they are adapting in a linear or angular way to fix your reference point, right? So this kind of measurement is called as a location of point by measurement of 2 points. So these are the two principles of a survey. Okay. Next, what are the importance of principles? Okay. First one, it ensures accuracy and reliability, right? So why it is ensures surveying principle guide and precise data collection and minimize mistakes. So that, as I said, as we discussed earlier, so there are two principles which are required to reduce your error. Okay. So there are huge possibilities of human error. So that should be eliminated. Next one is prevent error accumulation. There are two type of error. One is negligible, one is accumulative error. So if it is a cumulative error, you have to restart your entire research from the first. So to avoid these things, you can use this Principles of surveying. So it avoid compounding inaccuracy across the project area. Okay. So if you are measuring large number of distance, I mean distance between large number of points. So if you are starting with the error point, so obviously what are the measurement what you have measured for the entire day is wrong. So this kind of thing can be avoided. Next one, form the basis of repeatable and verifiable measurement. Okay. So if you want to verify your measurement, so you're having doubt on your measurement, if you're using these principles, you can clearly verify. So standard practice. So that's the standard practice of both of your principles. So to ensure can be consistently reproduced. Okay. So if you want to redo it, you can again do it. So because this is standard procedure which has a standard requirement to follow. Okay. Then, essential for design, construction, legal documenting. So, accurate survey supports safe design and execution of work. So, as I said, so it is essential for design, construction, and legal documenting. Because you are paying every square feet of land, everything is accountable. So, you should not be lenient on your documenting. So, it should be accurate and precise. What you have paid, you have to get that land. You should enclose other plans also. The next, classification of surveying. So after that, we have seen what are surveying and basis of surveying, principles of surveying. Now we are going to see classification of surveying. So in this, we are having four things. First thing, based on instrument. Next one is based on methods, right? So based on instrument, your survey is classified into chain surveying, compass surveying, theodolite surveying, flying table surveying, total station GPS surveying, drone and photogrammetry. Then based on method, it is triangulation, traversing, leveling, and tachometry. So when you are dealing with based on instrument, okay. So the chain surveying is used when you're doing surveying with a chain is called the chain surveying. So this is depending upon the instrument. If it is done with a compass, it is compass surveying. If it is done with theodolite, it is theodolite surveying. If it is done in a flying table, it is flying table surveying. So we are using total station and GPS for very precise estimate. This is called the total station and GPS surveying. So when we are dealing with drone and photogrammetry surveying, it is called as drone photogrammetry surveying. So this is depending upon instrument. So what that name they have given. Then method. So there are four methods, which is triangulation. If you are doing your area segregating, like working from whole to part, dividing your area into small triangle, it is triangulation. When you are dealing with a continuous open traverse or closed traverse, but measuring a boundary with your formula, you are calculating area, it is called as traversing. And leveling, you are calculating the RL, reduced level of your area, and regulating your water to flow, everything is dealing with the leveling. So when you are doing leveling and measuring your distance accordingly with the inaccessible point, then that is called as tachometry. So now we'll see in a detail. The first one is chain survey. So this is a basic and simplest type of surveying. You can only measure your linear measurement. Okay, so you can measure only the distance, right? Either your instrument will be made of a chain or a tape, and you cannot measure an angular measurement. You cannot measure angular measurement because you cannot measure your inclination of your lines. So that cannot be measured. You can just measure a distance between 2 points. So that is a simple and ancient method of surveying what they are using. Then compass surveying, when you want to measure the angle between your line, right? When you want to measure your bearing, not an angle, when you want to measure a bearing between your line, so that is called as the compass survey. So with respect towards your bearing, the difference between your forward bearing and back bearing will give you the angle, included angle between your lines. So that is called as compass survey. The next one is theodolite survey, right? When you are using theodolite for your survey to measure your horizontal and vertical angle. So this surveying is called as theodolite surveying. So this instrument is very precise instrument which is mounted on your tripod. So it will gives you the angle near to your seconds and minutes. Then flying table survey, this is older method. This is a graphical method. So in all the above thing, you have to measure and you have to reproduce your result in a drawing. Here you can directly reproduce your results in a survey, which is a graphical method in which a field observation is plotted, field observation and plotting is done simultaneously. Okay, so this is older method of surveying. When you are dealing with normal surveying, you can use it when you are dealing with a high precise accurate measurement. Then this is not suitable for that precise and accurate measurement of surveying. Right? Then total station in GPS. So total station in GPS, when you are doing measurement with the total station, you can use total station. It is an electronic and optical instrument that combine your theodolite for measurement and electronic distance measurement for your distance. So you are using theodolite for your angle measurement and you are using EDM for your distance measurement. Everything is combined in a single equipment is called as total station, which gives you your triangulation, traversing, and the distance area. Everything can be calculated with this single instrument. Then GPS, it used to regulate and precise position of latitude and longitude and elevation on the point of Earth's surface. So when you're dealing with a huge area, you want to locate your point with respect to your latitude and longitude, with respect to your direction, and your elevation can be given with this handy and sophisticated equipment. This is called as GPS surveying. The next one is drone surveying. So this is the latest and latest one which is used for your unaccessible point and very precise equipment, right? So you are using a drone to use this is called as unmanned aerial vehicle. It is equipped with camera and the LiDAR and other sensor to capture your data on top of your Earth surface, right? So this is called as photogrammetry surveying. Next one is drone surveying. So when the science of measurement is done in 3D model and 2D photography, so which is often captured by drone and aircraft on a ground camera. So this type of surveying is called as photogrammetry, which is very precisely used to give you a distance in unaccessible point. You can easily measure. This is very less time consuming and sophisticated method of surveying because you don't need a huge manpower to execute these things. If you are well equipped and well known on your operating your drones, you can easily capture a area of a huge area in a single handedly because everything is done on using your drone, right? So next we are going to see classification of surveying based on methods. So up to that we have seen your classification of surveying based on your equipment. Now we are going to see classification of surveying based on method. First one is triangulation. So as we have seen earlier, so measuring your area by segregating your area into small triangle is called as triangulation. Here you can see clearly that the distance between A to B is measured and you are dividing your entire area into small triangle. Then you are executing your work. So this kind of surveying is called as triangulations. Okay. So to determine the position of points which is spread over a large area, right? And we are measuring your baseline and angle of triangles using your trigonometrical calculation and remaining sides, which is used to locate your unknown point. You can see here, so these are the boundary points. So you are marking your area into small triangle and calculating your area, and then you are cumulatively adding all the triangular area will gives you a total area of your plot. So this type of measurement is called as triangulation. Then going with traversing is a circuit of line. So there are numerous numbers of lines are connected. So the distance between each line is measured with your compass and to include the angle and distance. So this kind of a measurement of surveying is called as traversing. There are two types of traversing. One is open traversing. You can see here your A and G are open-ended. So there is no connection. So this survey is called as open traversing. Then if your entire area is closed, so A and the last point are connected, so that is called as closed traverse. You can see here, so every measurement is given. So this is point A, this is survey station A, survey station B, and survey station C, D, E, right? So the distance between A to B is 61.5 meters. They'll be given clearly. So each all dimensions are in meters. Okay. So the bearing between A and B is 5 degrees. 5 degrees 7 minutes, right? You can see here the distance is 51.7 degrees. Here it is given. So the distance between B to C is 58.3 degrees, 58.3 meters. It is clearly given here. And the bearing between your B and C is 22 degree and 2 minutes. So that also given here. So like that, each and every point are marked precisely with respect towards your distance between them and the bearing. So this is called as traversing. So this is open traversing. Your line is open ended. Okay. But here it is a closed traversing because your measured area is completely closed between your enclosed area. Right. So the same thing. So A to B, the distance is 70.3 meters and the bearing with respect to north is 33 degrees. Like that, B to C, the distance is 60.9 and the measurement is 55 and the bearing is 55 degrees 0 minutes. Like that, every measurement will be there, right? So this kind of surveying is called as transverse. The next is leveling. Okay. So before that, we see that's the distance of an enclosed area with an angle. Now we are measuring your horizontal heights. Okay. So horizontal measurements. So elevation of your points with respect to your mean sea level. Right. So mean sea level is nothing but average. This average between your high sea level and low sea level. This is called as a mean sea level. With reference towards your mean sea level or a datum, you are measuring a height of a particular elevation of a particular ground level or particular point. So that is called as level. So this is very widely used because to initiate your construction, you need to take your traversing, then you have to proceed with your level. Everything is very precisely done because you are constructing a house which should regularly, which should align with your requirements, right? Then tachymetry. So tachymetry is a rapid method of surveying using decimal horizontal distance and elevation at the same time. You can see here, you're going to measure a distance between this point P and point A, right? So the distance is T. So with respect towards your leveling and your reading on your stadia of hair, so you can easily measure the distance with your formula. So here you can see D is equal to Kx plus C. So this K and C are constant and S is your stadia reading. So that we'll see in detail during our mathematics survey. So this is very precisely used. You can use to measure your distance without using a tape with your calculator. So this is calculated distance, not measured distance. So that's a huge difference between your calculator and measured. So measured is nothing but you are physically using your any tape or instrument to measure distance between P to A. So if you're using a tape or any other physical instrument to measure the distance, it's called as measured distance, right? If you are calculating the distance with respect to any formula, right? So that is calculated. So that's a huge, as I said, that's a huge difference between calculated and measured. Here you are going to use calculated distance. You are going to calculate the distance, not measure. So since the word calculator is used, huge manpower is not required. If there is a huge trench in between this, so you cannot use your tape. In that condition, you can go with this kind of surveying techniques. So thank you for your time. I think I will give a broad summary on this particular entire thing, right? So first thing we have seen what is surveying and what are the measurement, what are the classification of surveying, what are the principles of surveying we are used. So we are classifying a surveying, principle of surveying. We have seen working from whole to parts and triangulation, marking a third point with reference to a second point. Then we have seen classification of surveying based on instrument and method. So different type of instrument are used, starting from your compass surveying, right, and other type of surveying. Compass surveying, we have used chain, compass, tachometer, theodolite. So these are based on instrument. And the next we have seen based on measurement, based on methods. First one is triangulation, right? So same thing, you are measuring your area by splitting your area into small single triangles, right? Then we have seen with respect towards your traversing, there are two type of traversing. One is open traversing, next one is closed traversing. So everything you are identified using your technique. So next thing we have seen as now mapping everything is done, and we'll see the next day. We'll get back to the next video. Thank you.